So folks, we're going to count outcomes today, and we're going to do this by looking at the counting principle. So let's take Ben. I'm going to draw Ben right now. There he is. And he's going to start off at school. And from school, he can take 3 different routes from his school to the town center, and then 5 different routes from the town center to his home. What I want you to do is take a moment, pause this video, and look and see how many possible different routes Ben could take from school to home. For example, let's see, he could take this blue route from S to T, and then he could take this purple route from T to H. So pause and let's see how many routes you can count. Welcome back. Here goes. If you counted correctly, there should be 15 possible routes that Ben can take. Here's another example of where we want to count outcomes. Mom and Dad are going to take you to buy a new car. Lucky duck. There are 2 body types, a sedan or a hatchback, 5 colors. Not sure why you'd want this green though. And there are 3 models, the Standard GL, the Sporty SS, and the Luxury SL. So, how many different cars is it possible that you could buy? You're only buying one, but how many different cars are possible if there's 2 body types, 5 colors, and 3 models? Pause this video and think about it for a moment. Welcome back. A great way to visualize this is with a tree diagram. We could see that you start with your new car and there's 2 branches for car type. From the car, which I'm assuming this is the sedan, there's 5 different colors, and for each color there's 3 body types. So for example, you could have the sedan in black GL, the sedan in black SS, or the sedan in black SL. So if you follow down this route, you're going to get 3 possibilities. And for each color here, you're going to have 3 more. And if you do it with the hatchback, each one is going to have 3. So you should end up with a total, let's see, 2 bodies, 5 colors, 3 model types, and that should give you 30 different possibilities. Hopefully you see right now this idea of the counting principle. What do I do with the 2, 5, and the 3 to get this total? Okay, so here goes. The basic counting principle says that when there are m ways to do one thing and n ways to do another, then there are m times n ways of doing both. With that said, let's try a couple. Sarah goes to her local pizza parlor and she orders a pizza. What else would she order? She can choose either a large or a medium pizza. And then she has a choice of 7 different toppings and can have 3 different choices of crust. How many different pizzas could Sarah order? Pause for a moment, work it out, and then we'll check. So let's see how many choices Sarah has. Bringing this down, she had 2 sizes, 7 toppings, and 3 types of crust, so there were 42 total pizzas. Here's another one. Derek must choose a 4-digit PIN number. For example, like an ATM machine might need your card to have a PIN number. Each digit can be from 0 to 9. How many different possible PIN numbers can Derek choose? So here we go. Turn off, write your answer down, and then we'll turn you back on, or you'll turn me back on. You know what I mean. So here goes. There are 10 different digits that can go in the 10th, 100,000, 10,000 place. 10 different numbers that can go in the 1,000th place. 10, oh wow, that was really screwy. Let's go back. Ones, tens, hundreds, and thousands. So I take that back. There are 10 different numbers for the thousands place, 10 different digits for the hundreds place, 10 different for the tens, and 10 for the ones. 10 to the fourth is 10,000. Little further, how many even 5-digit whole numbers are there? Stop the video and give this a shot. Welcome back. Let's see what you could do here. When you think about it, the 10,000 place can't be 0. So there really are only 9 choices for that. For the thousands, hundreds, and tens, there's also possible every single number because of it can be 0 through 9. But the ones digit, if you're going to make it even, there's only 5 numbers it can end with, 0, 2, 4, 6, 8. So totally, there's 9 digits that can go in the thousands digit, or 10,000s, excuse me, 10 for the thousands, hundreds, and tens, and 5 in the ones, giving you a total of 45,000. Did you get it? Okay. I am going to give you another one here. How many words with 5 letters are there that start with a vowel and end with an S? Note, the words don't have to make any sense. Give this a shot. Here goes, boys and girls, and then turn me back on. Welcome back. Well, the first letter has to be a vowel, so there's 5 choices. The second letter can be any letter, so that's 26 choices. Sorry about that. The third can be any letter. The fourth can be any letter, but the last one must be an S. And if you multiply those all together, you get 87,880. Okay, the next 2 are going to be ones that you try at the end. So I'm going to skip these for now and then come back in a moment and just say that what we're going to talk about tomorrow is going to be combinations and permutations. What we mean by this is how many ways we can arrange objects. Now, we use the 2 words differently in statistics or in probability. Think of this sentence: my fruit salad has a combination of apples, grapes, and bananas. Unless you're a really finicky eater, it doesn't matter what order you put the apples, grapes, and bananas in. They're all there and you count that as one type of fruit salad. But now if I have the combination to a safe and I say it's 4, 7, 2, the order of the numbers matter. That's very different than 2, 4, 7. It's not going to open up the safe. When the order matters, we actually call this a permutation. So if the order doesn't matter in our arrangement, it's a combination. If the order does matter, it's a permutation. So really, when you open up your locker at school, it shouldn't be a combination lock. It should be a permutation lock. So now I'm going to give you 2 problems to try. Submit your answers, and we will talk tomorrow. Bye.